Hey guys, welcome back to another episode of Simuleos. I apologize for starting a little late today. Number of things, I don't know what's up, but I cannot seem to wake up on time lately. I mean, I used to get up at 4:30-ish, 30 minutes before stream. I could check some messages, do some stuff, but I don't know what's up. Today I woke up right at 4:55, so it takes apparently about 11 minutes for me to get started. And get ready. So I have to wake up at least at 4:45, I think. So I can get started at 4:55. Yeah, that's about right. But for some reason, I just have not been able to do that for the past few days, and I'm not exactly sure why. So let's go ahead and get started with how we normally get started, and we will work our way through what we need to do today. So let me go ahead and start talking about oak trees and Barnes Hut and things like that. So what are we going to do? Let's first start by drawing a box. Now, I was thinking about this the other day. I'm going to do what's known as a quad tree here. Quad trees are... Sorry with the young guys. Quad trees are two-dimensional analogs of oak trees. So quad trees are 2D oak trees. And we are definitely doing oak trees with this code. Now, the thing is, we could do quad trees. It's not that big of a deal. It doesn't make that big of a difference. So, why not, right? I mean, the reason is just because oak trees are kind of cooler in a way, So I'm kind of just sticking with oak trees, but in the end, for visualization, it might actually be easier with quad trees. I'm not sure. I haven't quite figured that one out yet. So we'll see what it looks like with oak trees, and then we can go back to 2D if necessary. That's just a matter of commenting out all of our Z stuff. Okay, so what exactly are we doing? Let's imagine we have a random distribution of particles, which I'm going to say are in blue. Something like this. Again, I'm just kind of randomly dispersing them about. There we go. Okay. What we're going to do is we're going to start by splitting the box into 4, or in 3 dimensions, this would be 8. Hence the name oak trees. So what we do is we split it into 4. Then we continually split each box again and again. That was meant to be a straight line. Again and again. Until all the particles are in exactly one box. Something like this. Forgive me, I am kind of taking some artistic liberties here. Okay. Here we are. There, here, there. Okay, something like that. Forgive me, I can't draw straight lines very well, but here we are. So now all the particles are in a single box. Now, with each of these boxes, we have a whole bunch of things that we're keeping track of. For example, center of mass, which I'm going to say is COM. For example, here, even though we have only one particle in the box, the center of mass is actually all the way over here on this side. Now, the interesting thing, and the reason we actually want to do this, is because later on we're going to be doing a, a kind of gravity simulator in a way. One second, let me check on Twitch real quick. I have to log in to Nightbot. Oops. And I should be. Yes, good. Just making sure. Okay. So we're going to be doing some sort of gravity simulator, which means this particle here has to feel the effects of all of these other particles. However, at some point, it's not so efficient to take into account this particle and this particle's effect on this particle, right? Because in that case, well, the effect of both these particles separately is negligible, but the power, the effect of both of them together is something that we need to take into account. So that's what we're going to do. The reason we have it split into this tree is that as we traverse the tree, hey Lawrence, what's up? As we traverse the tree, we can more easily lump the particles together into what they need to be lumped together in, so that we can more easily, how do I put this? Basically, so we can more easily understand the conglomerate particles effects. So the conglomerate particles effects on each individual particle. So we'll go through, we'll find every individual particle, then we will go along the tree, and basically the idea is if a set of nodes is, let's say, above a particular threshold, we then assume all of the nodes underneath it are all kind of part of the same big conglomerate particle that we'll be working with instead of having to go into the individual tree nodes. So for example, let's draw this structure as a tree instead. So we have, here's a circle here, 1, 2, 3, 4, okay? So then all of these split into 4 again, so we'll do this, and we'll say 1, 2, 3, 4, 1, 2, 3, 4. Preparing for vacation. Oh, cool. Where are you going, man? For me, I'm just doing programming. So all of them split into 4. Then we have some others that split into 4 too. Let me go ahead and draw all the nodes. Forgive me for not drawing this very cleanly or prettily. Prettily, is that a word? Yeah, actually, I have decided, guys, just letting you know. Again, I said this yesterday. I'll be taking this weekend off. I don't normally take weekends off, but weekends are kind of 50-50 for me streaming. I'm taking this weekend off because I gotta make sure I have everything else prepared for this simulation. Honestly, guys, though, if this simulation is, well, as straightforward as I think it needs to be, all we have to do is implement RK4, and RK4 isn't that hard. So we'll see how far we need to go from there. Okay, so then we have an additional couple of guys splitting up. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. And then we have this guy splitting up down here. Okay. From Belgium, about 10 days. Nice break from the studying. Oh, cool. Yeah, so my I have some of my family used to live in Spain. So they used to travel around Europe all the time. It's quite fun. So let me see. So basically all of the external nodes here count as particles, and all the internal nodes count as the bigger boxes holding other particles, right? So let's say we want to go from this particle to this particle over here, let's say. So we're asking this to this, okay? Well, at some point, let's say maybe here maybe, which is this big guy over here, we're going to just assume that these two guys share the same center of mass and are basically the same particle. And this allows us to, instead of traversing the tree to here, we only have to traverse the tree to here, which saves a little bit of compute time and doesn't lose that much physics, or that much, is not that big of a physical approximation, simply because the particles are so far away. And of course the force of gravity is F equals G m over r squared, where m is the mass of one object, m is the mass of the other object, and r squared is the distance between the two. So the further we are away, well, the less force we're going to see. And so for most forces that are like this, for example, the electrostatic force, F equals, what is it? EQQ? No. R squared. It's Coulomb's law, come on. Something QQ over R squared. The charge of one over the charge of the other. I think it's an E. No. EQ is just the force. 1 second. Oh, dagnabbit, there has to be a constant out here somewhere. Oh, maybe it's 1 over 4 pi epsilon. Oh, it's K. Yeah, 1 over 4 pi epsilon. There we go. KQQ over R squared. There we are. That's CGS. Let me see. CGS stands for... it's a unit type. I just don't remember what CGS actually stands for. These are in whatever units you want, actually. They're laws, right? So it doesn't matter which units, I don't think. Okay. So, this is what we're kind of working with here. This is kind of why we want to split everything up. Hopefully this makes a decent amount of sense. And if it doesn't, I apologize, you know? We're kind of working on that. So, let me get a quick sip of water, and then we'll go ahead and get started. So, again, I apologize for starting 5 minutes late today, guys. I did not intend to do that. That's actually kind of part of the reason why I want to take the weekend off. For some reason, I'm just exhausted. I don't know why. It could be work. It could be working out every day. I have no idea. It could be streaming. I haven't figured it out. But something is making me tired. I gotta figure that one out. Send me a gram. second. Yep, that should be what I thought, but for some reason it wasn't coming to me. All units are doing electrodynamic. Yes, 1/4 pi epsilon. Yeah, sure. Okay, so let's pop this over here, pop that over there, and let's go ahead and get started. So let me cd into the appropriate directory, project, Simuleos, and of course, Barnes Hut. And go over here and cd into projects, Simuleos, Barnes Hut. Like I said, I'm gonna get a quick sip of water, and let me know if you have any questions. Okay, I woke up a little bit late. This was completely filled when I woke up. It's now half filled. I drink so much water. It is ridiculous. Okay, so let me go ahead and press enter. So I have cd'd into that directory. Good. Okay, so let's go ahead and open up our Barnes Hut code. Now, if you remember last time, we had finished a good bit of stuff yesterday. Even though we had a lot of discussion, we still finished a lot of stuff. So we did the separating of the particle into a separate struct. We did this. We did the depth first search. Now we're working on the visualization. Now, at the end of yesterday's episode, I'm not gonna say chickened out, but I wanted to find a more intuitive way. I wanted to find an intuitive way to do it. I couldn't think of an intuitive way to do it. So let me go ahead and draw out what we need to do. And of course, if you have an idea to do it to do what I want to do easier, let me know. It's healthy drink. Drink way too little. Yeah, most people do. I find it like, I don't know, I just get so thirsty. Like, I mean, I suppose if you're addicted to any substance, water is probably a good thing to be addicted to, but seriously, I drink it so much. It's just like I can't even go to a lecture for an hour without drinking water. It's just not something I can do. Okay, let me put that on all desktops, and actually just so that I have this set, let me move this over there. Good. Okay, so let me talk about what we need to do next. New page before. We need to do some simple visualization, and for the visualization, we've decided to use NuPlot. Rather, I've decided to use NuPlot because, hey, NuPlot is awesome. Yeah, I mean, that's it. We'll just reuse it. It's fine. Now, NuPlot, what does it do? Well, it basically plots lines from one object to another object, from one point to another point. We can use the splot command. Don't ask me what splot stands for. It's splot. S stands for three-dimensional. So obviously that works out. So the splot plot, we'll do a three-dimensional plot of whatever we want. So basically the idea is if we want to make a cube, we will draw a square. There you go. Look at that perfectly drawn square. Draw a second square. And then we'll draw a third square up here. Fourth square down here. And we will have our plot. Now, alternatively, we could draw a square, and then this line, that line, that line, that line. Doesn't really matter that much. So let's just go ahead and do it. It won't take too long. Just got to draw the squares. And I'm expecting this to take like 20 minutes to do, maybe. And then we'll move on to the next bit, which should take a little bit longer. However, I want to make sure everything's working first with the octree code before moving on to the next bit, or unveiling what the next bit is, because the next bit might actually be the last real numerical part of this project. It could be that after this point, we do simply visualization, which could take a while, might not take a while, it depends. If we do OpenGL, it'll probably take some time for me to learn how to do everything, but maybe not as much time as you might think. We'll see how it all goes. There are a few visualizations I definitely want to try. Anyway, we'll talk about that as we get to it. Anyway, as I said, we're going to have to draw 2 boxes and a couple lines. What am I doing? Okay, here we are. Let's go down to the end. We already have octree output. Here's the idea. We're just outputting the octree file. Okay, so I said bottom square first. Let's do it. Here we have output. We're going to have to output the appropriate vertices. Now, with each individual octree cube, we have... My apologies. We have How do I put this? So let me check what we have in the octree. So let's go here, struct particle, struct node. We have a box length and we have a position. Really easy if you convert it to C++ syntax. Yeah, this is about what we're doing. Actually, this is exactly what we're doing. Cube XYZ. Yeah. Yeah. 1 second. 0 plus Y, 0 plus Z. Yeah. So let's go from here. So for the record, what was I gonna say? Oh. Replace all ones with extra argument size. Yeah. So here's what I'm gonna say. We have, what do we have? Position and box length, right? So the position is gonna be the center of every box. So what we need to do first is find all the vertices. So there are 8 vertices, and then we just go through and we go from there. Hey Slayer Darth, what's up? Okay. So we can do this in a number of ways. I think on the one hand, it might be best just to output everything outside of this. So let me see. What's happening here in the in this code over here is we're basically outputting, let's see, cube XYZ C with an additional color. And we're just printing it all out. Let me see. Today's the day I become a man when I run sudo apt-get install Sakura. That's the terminal I use. I like it. It's a clean, simple terminal. You know, it doesn't do anything for me. Also, guys, for some reason, I don't know if anyone here uses Macs, but okay, here's what I need for work. I need 6 terminals up for work, okay? So I have my 5 terminals up, all SSH'd into some local node or cluster or something like that. And then I have 1 terminal up that's on my own computer. Somehow or another, I don't know why, and I don't know exactly how, but the Mac OS, which again I use for work, continually freezes with the terminals. You'd think terminals, like they're the simplest thing to get right, you know? Like they use no processing power. It's literally just a connection to, you know, well, bash commands to do things with your computer, and yet it's freezing. Like every time I switch terminals or something like that. However, I will give it one positive thing. With Macs, if you press Alt 1, 2, 3, 4 while on the terminal application, it will actually bring you, if I press Alt 1 to here, Alt 2 to here, and Alt 3 to here. And that's quite nice, you know? It's like, okay, well, sure, you freeze all the time, but I will give you that was a nice thing to do. Okay, so now, we are basically doing this, and it's exactly like what they say. 0, 0, 0, 0, 0, 1, basically this guy here. So we just have to output everything appropriately. Now, we have to make sure we get the new lines and everything set. Let me see. Can we start at the lower vertex and go from there? We're using, I mean, the latest version, El Capitan, I think. It's not pre-OS X, I don't think. It's the latest version. The reason we're using Macs is simply because, well, we can afford it, and because you know, they are a little bit easier to use than, let me see, than Linux, and they have access to a terminal. I mean, that's the main thing. The access to the terminal is the thing that really clinches the deal. You know, without access to the terminal, it's like, you know, like for example, Windows, it's really hard to use when all your work is SSH'd onto another machine. You'd have to open up a whole bunch of PuTTY terminals, and it's just, it's not worth it. For a lot of people. No, that said, people do use Windows. I'm not saying they don't, but I'm just saying that it makes more sense to use Mac. Luculus 0, hey, thanks for coming in. Lower vertex is just position. Yeah, that's exactly what it is. So what we need to do is find that lower vertex, and then basically just do this, and then we're set. So let's do it. First, what we need to do is find lower vertex. Find the lower, let's say left vertex. This needs to be commented in. Okay, finding the lower left vertex. So here's what it's going to be. We're going to call it, how do we call it? Do I not have enough RAM? I would say we should. I just bought the machine. I don't remember how much RAM, but I thought we got 16 gigabytes. So I'd be hesitant to say we don't have enough RAM. I had that freeze a while ago. It was a setting in the terminal, but it's never happened since, so I can't remember. Fair enough. I went through all the settings to try to figure out what it was, and I even deleted one of the files that they said to delete to fix the problem. It still happens intermittently, but after deleting that file, it doesn't seem to happen as much. We'll see how that goes. Unfortunately, I can't fix it here, obviously. I can Google it again when I get to work. It's just, I don't know, I find it really weird that the terminal, of all things, is freezing up my computer. Okay, finding the lower left vertex. This is going to be super easy. We already have vector. Now let me go over here and open up what I believe to be vector.h. Yep. Let me check. XYZ. Fantastic. Yeah, so that's what I thought it was. They actually said to completely delete the shell configuration file. I'm not sure. So I'll take a look at it again over at work today, and we'll see if maybe there's another situation. But again, I did Google it last week and try to find a solution to it. Couldn't quite do it. But that's okay. Did I tell you guys, we have this local GPU box that we use in our unit, right? So the GPU box is basically just has one gaming card in it. That's all it has, but it's used for debugging and stuff before we send it to our cluster where we do most of our work. I had to recently install Arch on it, and it's now the most beautiful machine I've ever seen. Like it works wonderfully. I guess it's just because I know how Arch works and I know, like, you know, how it all happens, but it's so nice. You know, it is just one of the most beautiful things to have. I go on my Mac, I SSH into that computer, and then I have all of my typical commands: Pacman, Yaourt, obviously Steam Locomotive and ASCII-Quarium. Can't live without those. You know, it's great. Okay, anyway, I'm rambling. Let's go. Find the lower left vertex. What am I going to do? Well, we have the position, and we also have the radius, or what did I call it? Box length. So, to find the lower left vertex, we're going to say LLV. LLV. Let's do it. Because screw the rules, I have nothing. I need to install Arch at some point. I prefer installing from optical disk, but for some reason Arch can't find the disk label. Wait, I haven't seen anyone install from optical disk in a while. In fact, I haven't seen anyone with an optical disk drive. Like, my computer here, I just built it the other day. I spent like $2,500 on this thing. Like, this guy is like top of the end, or at least was a year ago when I built it. I don't have a CD drive. Just USBs. Okay, so LLV, lower left vertex. I hate the name, but that's okay. Let's go with it. So what's it going to be? It's going to be vec of the following. We're going to say it is, where are we? Current dot location, which I believe is going to be P, minus box length. Oh, sorry about that. Current dot, wait, lolcat. I don't actually know what that one is. Box length times 0.5. And then we do the same for the other dimensions. So we'll say current P dot P minus current box length times 0.5. And we do the same down here. Current dot P minus current dot box length times 0.5. Okay, let me add a comment here because I left one out. Okay, now let me see what this lolcat is saying. 1 second. No unicorns, but rainbows? Okay. See what it is. That is a lot of dependencies, but it's in communities. I can probably trust it. 1 second. This doesn't give out my IP address at all, does it? No, I don't think so. 1 second, I have to do a quick pacman SYY. Sudo pacman SYY. I just don't have much time after going over work. I need to start using other Linux distros other than Ubuntu. It's fine. It doesn't really matter that much. I mean, honestly, guys, when it comes to Linux distributions, the difference is not really as big as people make it out to be. You know? Let's see, what's lolcat? You gonna do something? Is it supposed to do something? It doesn't seem to be working right now. I guess I'll just Control C. It doesn't seem to pop up. Not sure why. I'll have to look into that a little bit later. Anyway. Good. Yeah, but as far as different distributions are concerned, like, I'll be honest, the difference is not that great. Yeah, so in my opinion, and maybe I'm wrong here, guys, feel free to correct me, but in my opinion, the only two major differences between all the distributions, every last one of the distributions ever created, the two major differences are, one, the community, which actually makes a huge difference. You know, like the Ubuntu community, completely different than the Arch community. They do completely different things when it comes to how they act and treat different people, and that's a big thing for me. The other thing is, of course, package management, which is the one most people think of first. For example, Arch, you just saw me use Yaourt, which is a way for me to use Pacman. Pacman is, in my opinion, the easiest and simplest to use package manager. However, if you're used to Ubuntu, then you'll probably say otherwise. And that's the thing, between the package management and the community, that's the only real big differences between the Linux distributions, because you can install just about anything on any distribution, right? So you could install OpenBox, you could have my setup on Ubuntu without too much trouble. I mean, it might be a little bit of trouble for you, but certainly you can have that. Okay, so let me see, Stargirl, I think it's one of the big differences. Like, I think Fedora and Red Hat use Yum, obviously Ubuntu uses apt. Yeah, the only other package manager I'm aware of is, well, only other major package manager I'm aware of is Arches with Pacman. Okay, so now we have to go through all of the vertices and draw lines. Okay, so let's do it. So what I'm going to do is I'm going to go over here and I'm going to copy this. Why don't you, like everybody else, use Windows 10? Honestly, Frank, it's because I just can't use Windows. Like, I'm not gonna lie here. I'm just not. I'm not gonna say intelligent enough, because I know a lot of people who use Windows just use it because it's what's on their operating system or what's on their computer to begin with. But it's just hard. Like, I've been using Arch Linux for so long that when it comes down to it, I just can't use Windows very easily. Wait. App was great, but it started leaving boot at 100%. Are you talking about having a very specific... let me see. I guess if you have a boot partition, and you put grub on that boot partition, yeah, it might do that. Not sure. So you want me to try lolcat a barnshut.cpp. Okay. Let's go into cd projects, Simuleos barnshut. Let me do lolcat -a barnshut.cpp. Oh, this is quite cool. Oh. Just in case. Let me see. Yeah, this is definitely something I needed. No, Gustrun's not... look, I use Linux. I've always used Linux. Rather, not always, but for the longest time I've used Linux. Ever since high school or junior high. Definitely used Linux. Just because it's what makes sense to me. You know, I'm not bashing anyone who uses Windows. Particularly because they have Bash now. I'm not bashing anyone who uses Mac. It's just how it is. I've been using Arch Linux for the longest time. I see no reason to quit using it. Control C. That was pretty neat. It doesn't really have very many practical uses, but neither do most of my other commands. Okay, so let's go ahead and redo this. So, hey Gustron, thanks for coming in. Basically, we have to just copy these vertex changes, and just to make sure I have this right, let me see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let me go over here and let me do something real quick. So here we're gonna say a couple spaces there, 1, 2, 3, 4, 5, couple spaces there, 2, 3, 4, 5, couple spaces there. Okay, so this is how we're gonna split everything up. Gustron, Frank, he's not doing anything. Sorry, Slayer. Yeah, I'm not known for having the best jokes. Okay, so basically we have to recreate this, draw all of our boxes, and then we'll be set to go. I have to dual boot Windows for work now. Unfortunately, I have to make things work with Visual C++ too. Yeah, I mean, here's the thing. A lot of people claim that the C++, I guess Visual C++, what's the IDE you use for that? The Integrated Development Environment. A lot of people claim that is the #1 IDE created. Like, they just say it is the best. That said, I don't know. I don't know. If it is, let me know. Like, what do you guys code on? Is it Visual Studio, or do you guys code on something else? Like, if you're on Windows, what do you use to do the programming on? You know? Okay. So let's do it. Looks to me like it's 0, 0. Is it Visual Studio? Okay. So let's go ahead and draw everything out. Wait, what? Wait. Slayer Death, I think I missed something. Are you saying that Gustorm doesn't like passwords? Oh, Richard Stallman. I see. Okay. Let's go through. So we're gonna say output. And honestly, guys, I go with Vim still, but Visual Studio Debugger is really, really good. Ah, good. Good. Okay, so we're gonna say output, and we're going to do this. I'm just gonna output all these positions appropriately. So let's do it. We're going to say LLV plus current dot box length. Okay. So let's see. It's just gonna be the lower left vertex to start. Tab. Lower left vertex. Tab. Lower left vertex. New line. And let me change this. So it's gonna be here. X. Oh, dagnabbit, that needs to be a Y. Y. And Z, of course. Okay, so we're just gonna have to do this for pretty much everything. And I think we'll be good. Let me see. I missed something. Using Adam's CMDER for using Unix shell commands. Command DR. Oh, fair enough. Okay. Let me see. It's so slow though. Same goes for Adam. Computer science. Frank. Something to propose instead of CMDR, because I can't deny it's slow. The only other thing I know about is Cygwin. I'm really bad at Windows stuff, so that, guys, sorry about that. Okay, so here's what I'm going to do. I'm just going to go ahead and let me try something. I haven't yanked and pasted in a while. Forget how to do it. Let me see. 4, 5. I got it. Okay, I forgot how to yank and paste. I always forget how to yank and paste. So let's go here. 2, 3, 4. That's what we need. Okay, so now let's modify these up. Okay. So, we have LLV's lower left vertex. Of course, it's for 3D, so maybe it should be lower left vertex? I'm not sure. Anyway, it's okay. You got it through... Wait. You got a GitHub page? I don't know how to turn it. It's the best thing in Windows. It's really slow. Okay. That's all you got. Sorry about the folio, Starby. Okay, so let's keep working on it. So LLV.x. These are all going to remain the same. However, these are going to change. So again, I'm just copying what they have up there. So it's not so big of a deal. So here we're going to say plus current... dot box length. Okay. XI plus. And let's just keep moving on it from there. So now we have to do another plus current dot box length here. Let's do current dot box length. Okay. And I realize, guys, this is quite slow, but you know, this is the only way I can currently see of how to do this. And of course, if you have other ideas, as I mentioned before, just let me know. Dot box length. Okay, so this is for Y. And let's just go ahead and do this. So now we have to do just Y here. So I think it's there. Good. And then it's all back to 0. Good. So let's go down here. And these are now all 1s. So let's do 1, 2, 3, 1 second, 4, 5. Okay, then we're gonna have to have 2 here. 1 second, 1. And I'll worry about formatting in just a second, guys. And then it looks like 2 Z's here and here. Okay. Free stuff is bad for the economy anyway. Good riddance. Let me see. So we had 2 Z's. Yeah, this should be right. Okay, so now let's go down here. Looks like we have 2 X's. These 2 right here. There. And there. What's the next one? We have 2 Y's. Let me see. 1 here in the middle. And another here. And then for Z's, we have nothing on Z's. Okay. Now we go down here. All of these are being used. So let's go here. Z, 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 Z. Z, okay. Now we have 2 X's and 2 Y's. Here. There. There. And here. Okay. So this should be about right. Again, I'm going to worry about formatting now. Excuse me, by the way, at school, in a school called 42. Well, at least you're going to learn everything there. Okay. So let's see, what do I want to do here? Output. Let me go ahead and move some of these guys around so that they're a little bit easier to read, at least in my book. I guess that's all I need to do there. Move Z down to the next line. Here. Next line over here. Oh, I don't know about that. So all my friends, or not all my friends, if I only had 1 friend, then all of my friends, but I have at least 2 friends. But a lot of my friends are now using ZSH, and I don't know the benefits, actually. If you guys could enlighten me, that would be great. Because again, I have nothing against it, obviously, I just don't know how to use it. So let's go over here, and let's see, tab. There. Oh shoot, what am I doing with my life? And remove that space. Let me see. What do we have here? Yeah, I mostly use Sublime Text nowadays too. It's consistent across Linux and Windows. Windows version of Vim is really sluggish. I didn't know that. Thanks for letting me know. Or letting us know, I guess. Okay, so let's bring Z down to the next line. There. And of course do it down here too. Let me see. I don't think Gustorn is Texan. I mean, of all states, I think Texas is one of the ones that he's definitely not from. So let's go here. There, and let's see, what else do we need? Z's down there. Okay. So guys, here's the way I see it as far as like giving out personal information on this Twitch channel or whatever. Do know that all of this stuff is going to be posted again on YouTube, right? So it's going to be forever in the archives of the internet. I'm letting you know that so that you don't post anything too personal. I'll try to, if you guys accidentally post something super personal, I'll try to, like, you know, blot that part out. But I'm just letting you guys know, just be careful, you know. Again, obviously no one's going to do anything bad with any of the information, just throwing that out there. Because right now, giving out locations, that's not going to do anything. Like, everyone knows I'm in Okinawa. Everyone knows that, you know, several of my viewers are in Europe. Some are in America. That's fine. You know, that's not going to do anything. Just don't give out, like, don't give out any, like, don't say my address is 345 Cranberry Lane next to the, I don't know, soda pop parlor or something. No, I don't think the aimbot would give me that many views. That said, you know, it's not, we do what's interesting. Okay, let's go here. Now, what I want to do is I want to output just the root box. So let's go here and let's see what happens. So where is our main function? Here it is, output.close, output there, and let's do it. So we're just going to say octree output, and we are going to say the root box. So we're going to say root and then output. Okay, let's see how it breaks. Dragnet MC. What am I programming here? Let me see. So what we do here is we basically do physics algorithms, right? It's not for anything in the end, so don't get your hopes up that this is going to turn into a game or something like that. What we're actually doing is we are basically taking a whole bunch of particles and we're treating them as if they were trees. And by that I mean we're treating them as if they were the programming tree, right? So this is called an octree code. The idea is that we better find the positions of particles by putting them into this tree format. Then what we're going to do is put a force integration algorithm over everything so that we can basically see, well, galaxies and things move around. If you go to my channel right here, there's a link right under the stream in the info to something that says Barnes Hutty, which is the algorithm we'll actually be using. And this will give you a bit of a better idea of what we're actually doing here. So hopefully, hopefully this helps a little bit. So sorry, I kind of go through the first 10 minutes of every stream and kind of go through everything in detail and ask for questions, and unfortunately missed that. DSH has quite a bit of cool stuff for it with plugins, partial history, Git integration, better tab completion. Ah, fair enough. So let me now run make, and it's gonna break, but that's okay. That's okay. Okay, so the problem here is that we're using pointers. So let's go here. G. Simulus, I follow you since months now. I didn't know you had a YouTube channel. Gonna watch your videos day and night? Sure. Thanks. I have two YouTube channels. One where I post the streams, and that's just Simuleos, and another where I post kind of the output of our simulation. So I put, like for example, I did one on eigenvectors a while ago, Monte Carlo. Then we did one recently on the invisible lens stuff, or the lens stuff in general, one on Maxwell's Demon. I'm kind of super behind though. There's a lot of simulations we've done here on this channel that I haven't put up on YouTube yet. But yeah, that's how it is. So that channel is Leos OS. Seems very complicated, but I'll stay around for a while and see if I tag along. Oh, well thanks Dragnet, I appreciate it. Okay, so let's see. Everything here is of course broken because I'm an idiot. It happens a lot, you know. Okay. So let's see, what do we have here? Current P, so let's go ahead and get this done. So first of all, LLV is wrong because we're using, not a problem, Slayer Darth, happens all the time. So let's go ahead and get rid of all these dots because these dots are going to be a problem. Because we're using pointers, we have to give them arrows, which I knew we had to do, I just forgot. There we go. Oh, that's okay. So I think LLV.Y and X should still be fine. What I need to do is fix all the box lengths. So let's go here. Not a problem. So let's go here. And what I'm going to do is I'm just going to look for box length. This will help me out a little bit. What am I doing? X here. X, 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 X. Let me see. Oh, that's actually fine. Good, fantastic. X. X. 1 second. Oops. Man, I'm just not doing well with this. Next. Here. There. 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 Any others? There. Oh no, I did it again! And what's next? There. Oh, there's more. And let's see, what else is there? Oh no, this is gonna screw up my formatting. Ah, crap. Okay, that's okay. We'll do it. We'll do it when it comes to it. So, box length. We're gonna say A. Oh, never mind. I want to do I. Arrow. Good. So now I can just do N and dot. Oh shoot, never mind. I have to do N dot. N. Oh no, shoot. What am I doing? N and dot. Oh man, I screwed this up big time. Okay, let's try that again. Arrow here. There we go. Now N dot. There we go. One second, this is taking a lot of my concentration. Oh, dang it! Done. Okay, let's go down to the bend. And yes, I could have done that. Thanks. I always forget Vim commands. The problem is that I didn't want to modify like the whole file. I only wanted to do it for a few lines. You know what I probably could have done? Ah, dag nabbit. I'm just now realizing I could have done this. I could have done, you know, from like, I don't know, 3, 4, 5 to 4, 5, 3, 4, 6 or something like that, whatever, S. Then I could have done the to and from. Forgive me, I'm an idiot. I'm an idiot. Okay, I missed a couple of people there saying some things. I apologize for that. It's okay. I'm using VI, so I don't have visual mode. Okay, so let's go down here. And let me go ahead and fix some things. Let's fix this. Let me go over here. And let me fix this. There. I'm just going to fix some formatting, guys, and then we will try to run it one more time. It's just, you know, personal habit. Tab. Here. Go to the end here. And that. Do the same thing down here. And that. Let me see. Those are sort of environmental variables. Emac are evil. For environmental variables. Let me change the air conditioning mode over here. It's getting kind of hot. Okay. So let's keep fixing the formatting because look at me. I know how to do nothing. Okay, so let's go over here. Fix that. N, new tab down here. Okay. Dang, just barely off the line too. It's okay. Tab, and here. There. DD. Okay. Yeah, so honestly, I've never used Emacs. I've always just been a VI guy. New line? Oh, that one seems fine. So we'll just go to LV here. Yeah, I've always used VI. Maybe I should give Emacs a chance. I just haven't. Okay. In fact, it was kind of interesting. The other day when I was on Twitch, our Twitch or something like that, and I was doing, if you want to make vector printing shorter, open link. Is this with OSStream operator? Yeah. Yeah. That would definitely help a little bit. But it's kind of too late now. I already have everything kind of set. You can always try Spacemacs. It uses VI commands to keep all the Emacs and keeps all the Emacs commands too. Okay, let me see. What do I need to do? I also need to do the following. Between each of these guys, I need to do output, new line, and new line. This is just so that, let me see, just so that new plot knows what we're doing. We don't need them down here, but I'm going to put them down there too, because actually we might need them later. Okay, so now let's run the make command again. Okay, so we just have a few errors here. Okay, one is that I missed something on 336. Here we are. I missed a dot here. The other one is on 301. Which is a bit of a weird one for me. So let me go to 301. It says output not defined. Let me see. Output was not declared in the scope. It's weird that it's at 301. 1 second. Augusta, I use it almost exclusively. You've got to remove a dot in the 5th line. Ah, thanks. You just got it. Appreciate it. I use it almost exclusively, but there with the last updates it broke somehow. So now my things work sporadically. Actually, a lot of my friends use Sublime. Okay, what am I doing here? Why does it not recognize output here? Did I misspell output? No, output looks like it's spelled correctly. Conversion argument to double the vector. One second. What is the issue here? No known argument. Oh, does it not like the current to box length thing? Here, let me run this again. Make. Okay, so give me just this one error. Let me see what happens if I remove a little bit of this down here. So, I'm going to remove this section here, just gonna quickly comment it out, and let me see if it's okay with this. Let's go here to make. Output was not declared in the scope. 301. No, it's okay with that. Good. Okay, well that's fine. No known conversion argument 2. Let me see. Hacker joked that there is a proposed method of creating a pseudo-random character sequence by having a user unfamiliar with VI. Oh yeah, seated in front of an open editor and ask them to exit the program. I mean, that's true, right? I was thinking about, like, at some point making a bunch of t-shirts that just say :WQ on it, and like that's it. Let me see. Lawrence, Gustorn, yes. That happens if you don't remove all the modes, themes, yeah. Vim manages to handle it with all the plugins. Yeah, larger files are something I honestly, I'll use like Nedit or something for. I need to find a better solution to those. If I missed any of your chat messages, just repeat them. I apologize for that. Also, an easy way to make sure that your chat message grabs my eye is to just type Simuleos at the start of it, just to say, hey, you're talking to me. Okay, let's see. It actually looks like there are a few errors here, so let me go ahead and clear up a couple times. Let's do make. Okay, so yeah, there are a few of these. It doesn't like current position here, minus current box length there, and I can understand why. So let's go up here. I need to put an X on all of these guys. So .x, .y, and .z. So right, that should fix some things. Okay, so now let's see. Expected comma or semicolon before output. You should have one. Oh, let's go to 300. Yeah, that's where you're missing the semicolon, right there. Okay, so let's try this one more time. Write this, go over here, make. Okay, output was not declared in the scope at 300. Let me go up and see. We are reading in file is what we're reading in. So let's change that to output, just because I don't want to change all those. Let's go to output. If I can spell anything. I really like the challenge that Crams and BPAF passed a while back, exiting Vim's easy mode. Yeah, I never figured that one out. The staff is a joke. Instead of typing clear, you can press Control L. I know that actually. In the back of my mind, every time I type in clear, I know that. But for some reason, I type in clear every time anyway. Like, it's one of those things I should not do, but I do anyway. So let's go down to find file. Here, there it is, and let's change this to output. Good. Let's go over here and make that. File was not declared in the scope. 347. 347. Oh my gosh, 347. Let's go. Octree output, output. Okay, for auto child and current children. We output everything. For this, go over here. Now let's make it. Good. Okay, seems to do something. Now let's look into out.dat. It looks like we have everything we need. 2 lines between all of these guys. What I'm just going to do is plot it. So let's go over here, quit. Let me CP a file over here just so I don't get anything wrong. It's going to be, I think, under tests and something.gp. One second, let me CD into the appropriate directory by opening up a new terminal. So I'm going to CD into projects, Simuleos, oh no, tests, sorry about this is a separate directory. Final report schloss as.pdf, probably don't want to open up that one. Cubeplot.gp, that's what I want. Okay, so it's going to be, one second, CP, tests, there we are, and then cubeplot.gp. Oh, here. No, I don't think Gustorm's particularly angry at this point. Instead of typing clear, Control L, good. Okay, so let's take a look at this. Let me go into cubeplot.gp. There's a whole bunch of things we could do, but for now, I'm just going to change this to out.dat. There we go. Right, quit. And now let's do new plot, cubeplot, minus. Let's see what it looks like. Okay, so this is almost right. Almost. We have, for some reason, some lines that are not supposed to be there. and the cube isn't completely drawn. So here's what I'm going to do. I'm going to comment this guy out down here. Let's just see if we can get the root box drawn, and then we'll go from there. Right here, go over here and run Control D, make. Let it run one more time. And then we'll go from there. New plot. Okay, so let's take a look at this. We are connecting the wrong lines here and there. We should be connecting these two lines, but we're connecting those two lines. If we can fix that. Oh, and this line here. Oh, interesting. Okay, so we're almost there, but for some reason, one of the boxes isn't being drawn correctly. So we got to fix that one. Let me see. Showing Windows Manager and mini terminals. Let's see. Actually, what do Control Q and Control W do on Chromium? I'm not sure. The staff is a joke. Question to Vim guys. How do you handle a big project? That's the only thing that keeps me from using Vim. I mean, I just have multiple terminals up. Exactly like Mugata said. I basically have 6 terminals up, and it's quite nice because it allows me to look at all of the code at once, you know? However, you know, there's a whole bunch of search and stuff things that you can do in Vim, no problem. Okay, so let's just comment out some blocks. I'm pretty sure that these guys are working okay. So let me check this out. I'll put this, but I think the bottom two is where I kind of got lazy. So let's control here. Let's remove out.dat and let's make it again. Now that should really make anything done. So now let's do new plot. Okay, so here we have these two boxes. Oh, those two boxes are actually drawn correctly. So let's DD here. And DD there. Go down here. There. And of course, here. Now let's do Control D. Make one more time. Let's do new plot. Okay, so that's the one. Right here. This side. I betcha it's either the first or second, right? So let's go from there. I'm using new plot. Yep. Let's go over here. Control D. Make. Oh, my bad. Make. What am I doing? I know what I'm doing. I forgot to open up the commenting box. There we are. Right here. Go over here. Make. There we go. Now let's run new plot. Oh, what the what? I now realize what I'm doing wrong. I want all of these guys commented out. I'm just trying to check whether it's the first or second one that we're having trouble with, and then we can narrow it down from there. Right here, go over here to Control D, make, then let's do new plot. Okay, so that one seems fine, so it has to be the second one then that we're having trouble with. So let's comment this guy out. DD here, and go down here. Good. So now we have just a second one, Control D, make, and this one should be broken. Let's go to new plot. Yes, so this is currently the one that's broken. Okay, so let's see what we need to fix here. Let me see, did I miss something? Some of my friends work on a 500 by 500 shell Vim screen on a 4K screen Mac, doing their project like nothing was wrong. Let me see. Let me get a quick drink of water. I'm getting a little parched. .4K Mac, because iOS simulators need to be scaled properly. Okay. Happy little rat, yeah? Okay, so let's see. What did I do wrong here? Let's see. It should be llv.x, llv.x. All these are current plus box length. Then let's see. The first one should be 0, 0. The next one should be 0, 1. Correct. The next one should be 1, 1. So let's see. 1, 1. Correct. The next one should be 1, 0. 1, 0. Correct. And then the next one should be 0, 0 again. That actually looks correct to me. Oh, because I looked at the wrong... The heck? What am I doing? How did I... I was looking at the wrong one. This is the joke. Don't you have smaller... No, this is a liter. It is a full liter. But I'm almost done with it. Okay, see, what do we have here? LV.x, current box length. Current box length, current box length, current box length, current box length. Okay, Y, Z. Oh, well that's incorrect. Let's remove this one here. Okay, so let's see, what's the next one? 101, 101, seems good to me. 111, 1, incorrect here. Pointing to box length. Let me see. The staff is a joke. Like going to a definition, I tried tags, but it doesn't work because the project is in many different folders. Searching or something replace in the whole project is another thing that I don't know how to handle except with grep. Yeah, you guys definitely are talking about other things. I don't know if I can help with that. Thanks for running now. Don't you fill up the bottle at the sink? I mean, yeah, I've got a water filter and I fill it up at the sink. Let's see. Box length, box length, box length. Okay, next one. We want 110. So it's going to be 110, correct? Next one is 100. Yes, okay, this one should work. Make. New plot. Okay, good, we have the square. So let's plot them all again. DD here. DD there. DD. And DD. Right, this, go over here. Control D. And make. Okay, now let's do new plot. And it looks to me... There we go, we have our base cube. Okay. Water poison in Japan or something? No, the water is fine. Install you completely and you get Clang based stuff, which includes go to definition. No global rename yet. I see. Okay, so that is our one box. Now let's plot everything else. Again, this is a recursive way to plot all of the boxes. Go here, let's go to Control D, and now let's make that. Take a look at all the boxes. There we go, look at that. That looks like an octree. Kind of. You know, we're getting there. Okay, so I'm gonna have to do some resizing and stuff like that, but first, let me go up here. And let me also plot out something else. So I want to do that. And then I also want to plot particles. Water filter or whatever you say, turn it, you're drinking your own. No, I'm pretty sure Japan is safe. Japan is one of the many countries that I'm pretty sure is safe. Okay, so now what I want to do is output all the particle positions. And I also want to change the terminal size and stuff like that for new plot. So let me go ahead and do that real quick. So Control D over here. Let me open up another file real quick. So let me write and quit. Is there some language that Vim is designed for? Because Emacs is mostly for Lisp. So it's no surprise that the closure modes, for example, are very good. I'm actually not sure, Lawrence. If I knew, I'd definitely help there. So let me open up another file. So let me go into, 1 second. I believe it's going to be an FDTD. Then let's go to Evanescent, maybe. Sorry for the yawn, guys. And there should be something.gp, evanescent.gp. Oh, that was not what I wanted. .gp. Nope, GP. Okay, so let me just go ahead and set some things in our cube plot file. So let me go over here to cube plot.gp, and let's just add some things here. So I'm going to grab this guy is the one that I want in particular, but I think I just want to grab this guy. I think set terminal size, that should be okay. So let's grab that and let's put it up here. Oh, there we go. And this isn't going to be for FDTD. It's going to be, what do I want here? I want, octree data. Okay, so here we have this. Let me try something real quick because I'm rather interested to see how this turns out. If I uncomment all of these, I'll create a shaded cube. And I want to see what happens. Oh, out of memory. Okay, it doesn't like that. So let's just go ahead and get rid of these guys because they're not going to help anyway. So let's go ahead and remove all of these guys and just leave the simple splot command. Right and quit. New plot. Okay, here we are. Everything seems fine to me. It's I kind of wish it was square. But let's see. Is it going from where we want it to go to? It is correct. I mean, it's not quite square, but it is correct. Okay, let me change the line width too. Control D. Cube line width. I think that's just going to be LW2 or something like that. Let's try it again. New plot. There we go. So it's a little bit easier to see now. Now we have to plot all the particles. So I'm going to output a new file with all the particles. Out of 32 gigabytes of RAM. I don't think that's what it was. This is out of memory. I don't know. I'm not sure exactly what was happening there. But that's okay. Not a big deal. Good. So now let's output all the particle positions. Right and quit here. What do I want to do? Let me go into our files. Let me go into Barnes Hut. Again, .cpp. And now, what do I want to do? I want to go down here, and let me think. I want a separate output file. So, let's go down here. And I guess we'll just do an output positions type of thing. Let's see, how are we holding all the particles? Yeah, we should totally do it that way. So, let's go down here, and let's say function to output all particle positions. Now, this is going to come in handy a little bit later. This function will be used to plot out what particles actually see with the Barnes Hut algorithm for gravitational / electrostatic forces. Good. Let me see. Out of memory, Slayer Darth. Not sure what this means. Just seems to be Firefox add-ons. I will open this, but I might not be able to help. So let's go down here and let's say void. And we're going to say particle output. So, what do we want here? We want node current, whatever node we're working off of. Then we want std upstream. And this time I'm going to say p output. Yep. It's going to be simple for this to start with, and then we'll kind of make it more complicated as we go along. So let's grab this, go down here, and we're basically going to copy what we had before. So let's do here, void particle output, grab this, and we're going to say function. Oh, come on, I can spell function. To output particle positions. Fantastic. Okay, we're going to go down here. We have the current. All we have to do is go through, output the particle positions, and that's about it. Have you ever tried overclocking that i7? No, I have not. I haven't really had a need to overclock it because, again, I don't do very much gaming. And for most of my simulations, that simply means running the simulation for longer, which isn't usually that big of a deal. Let me see. And most times, I don't actually hit all 6 times 2 cores in here. I think that's what I have. Yeah, 6 hyper-threaded cores, I think. I bought it because I wanted 12 cores. That's what I bought it for. And then I realized I don't use all 12 cores very frequently. So what I want to do here, I want to say, I guess we just output the particle positions, right? I don't see any reason to make this any more complicated than it needs to be. Yeah, so let's do it. What's this? If current return? Yeah, let's grab this. And then we'll go down here. Down here. There. Paste. DD. Now we're going to say, what are we going to say? We're going to say p output the following, and we're going to say current dot 1 second, 4 cores, 4 hyperthreads. Yeah. So let's say current dot p dot x, new tab, current dot p dot y, new tab, and current.p z, new tab. Good. And now we're just going to do the same loop we did before. We're going to say for auto child in current children dren. Come on, I can spell children. We go down here and there. you'll max out at, I don't know what BF1 is. Is that like, no, I was thinking Dwarf Fortress or something with the F. I don't know. So let's now do particle output. And we're going to say node current. So it's going to be current. And P output. Okay. So that should be it for outputting everything. And let me just go ahead and leave a quick comment. Recursively outputting internal boxes. And let's go down here. Yeah, I would think so, right? And we'll go here and we'll say recursively Battlefield 1, thanks. Outputting, let's say additional particles. And you know what, I just realized something. Here we will be plotting the internal nodes. The position of all the internal nodes. But I think that's okay for now. We'll leave it for now, and then because I think I want to see the internal nodes. So I guess I will leave, we'll fix that in a bit. Let me go ahead and plot the internal nodes too, because I think the internal nodes are actually super helpful here. Yeah, I think they'll be super helpful. So we go up to main here, and let's see, what do we have? Upstream output, same thing here. So I'm going to do std, upstream, and I'm going to say p output, just like I did before. And we will say pout.dat. Then std upstream out. Okay. You're using YCM. Good. Now, what do I want to do here? I want to do octree output and then particle output. 1 second, and I want to do root, and of course p output. Good. Let's go ahead and comment that in, out, whatever, and let's make it. Of course, I have some issues. Let me see, 365. There we go. Yeah, I forgot the arrows again. I keep doing that. I don't know why. That's me just not, for some reason, remembering what I'm doing in this code. So, arrow again. And let's do the same thing here. Chirp. Chirp. Good. Now, what else did I forget? Current. Looks to me like that is about it. And actually, I just realized we need to be outputting child, not current. And let's make. Okay, that seemed to make okay. Now let's go into the cube plot file. And let's do splot. I want to do pout. .dat. Using 1, 2, 3. And I actually don't know what this parentheses does, so I'm just going to put it in there because why not? ls1, again, not sure, so I'm just going to say that too. Why not? And then line width 2. Run quit. Now let's run the last new plot command. Well, that's not right. Control D, up here, VI cube. I think I need to do R. No, that didn't work out. 1 second. What is this? It's pretty old, 2500K, 16 gigabyte RAM, 6970. Let me see. Yeah, you're right about that. I kind of went with Intel. Let me go here. Is it re? Gosh darn it, I forget all my new plot stuff. Let me go ahead and quit here. Let me run new plot. Plot. Where's all my replots? Let's just do plot out.dat. There we go. There we say, it's rep. That's what it is. Let's go here. Let's do, there we go. R-E-P. Man, some of my friends would give me a lot of crap for that one. There we are. So we have this, and then where are all the particles? It looks to me like we're not plotting all the particles. Because I bet... that's fair enough. I mean, I use CUDA all the time, so in some sense, I suppose I am an NVIDIA fanboy. But I mean, I don't... It's just that a while ago, NVIDIA was the only operating or the only graphics card vendor that would actually work well with Linux and stuff like that. So it was kind of the only option we had. But now we have different options. So again, maybe nowadays I might choose something else. And in fact, AMD works quite well with OpenCL or OpenCV. OpenCL. Yeah, OpenCL. Yeah, I agree with Gustron. Like, now I'm looking back at the 970, and again, I kind of regret buying it. It's not like it's that big of a deal. I kind of feel like I could have done something else. So current children, particle output, child P output. We are actually not outputting the actual positions of any of the particles here. Okay, so let me check something. Let me go up to where we have everything. Sell it. Let me go ahead and remove these because they're no longer necessary. Okay, now let's go up. So in our octree function, what are we doing here? We have the center of masses. Oh my gosh, of course this isn't going to do anything. Let's go down here to G. Particle output, let's see, it's not position.x. Let's output the center of mass of x every time. See what happens there. This, I think, should do it. Brings it down to the next line. Right, let's go over here and let's run Control D and make. There it is. Center mass position.x. It's kind of weird. Let's try it again. I'm not liking this whole center mass position thing, but that's okay. Make. Okay, now let's do a new plot. And let's see what we have. Still not plotting the positions, which is a little bit weird. So let me do something else then. Let me do Control D. Let me go into the new plot file. No, let's just do new plot. And let's plot. 1 second, splot. Where's... Okay, fine. Let's do p out.dat. Control D. VIP out.dat. Oh! Well, that's quite interesting. Yeah. Quit that. Go from here. Let me see. What did I miss? Doesn't NVIDIA throttle performance some of their newer cards or something? You're probably talking about the 970, which is the one that I got. And yeah, something like that is... it does happen, I think. Let me go here and let me change this to a new line. Now let's try this. Control... I just exited my terminal. I'm sorry about that. I don't know why it's all white now. Okay, there we go. CD and projects, Simuleos. And then I need to go into Barnes Hut. I think it's capital B. Barnes Hut. Okay. LS here. Okay. So now we have a new line here. Let's go over here and make it. And let's see what happens. Sorry, Darth. By the way, Gus Torn, are you any good at linear algebra? Let's go over here to new plot. Okay, this is looking a little bit fairer. Okay, so now what we have to do is kind of zoom in here. Oh, oops, how do we zoom in again? I think it's Control Scroll. Oh, we have to figure out if all of these have one particle per box. So let's see. This big box has one particle. That big box has one particle. Let's see. Let's look from up here. Looks like we have one particle there, one particle there, one particle there, one there. Let me see. It almost looks like we haven't split it up appropriately. Let's try with more particles. Yeah, let's try with more particles. Because I just realized I don't get why a variable to the power of 0 equals 1. What you can do for that... 1 second. I missed something. I missed a lot, actually. Don't worry, 970 is pretty dank card. Let me see. A to 0 is equal to A, so 1 minus 1. A over A equals 1. Yeah, that's actually a good way to put it. In fact, that That's actually one of the simplest ways to put it. Okay, so let me go ahead and do that. Okay, so now I want to do the following. We're going to do the particle output, but we want to say if... How do we do this? How do we say if there are no children nodes? How do we say if this is a final node? So let me see. Oh, I know what we can say. If pvec equals 1. So we're going to say if pvec dot size. Oh, what is it? It's probably going to be current, pointing to p vector dot size equals 1. We go down here and we output. Okay, just to make sure I have this right, let me search for pvec. Just to make sure this isn't the only time I'm using that notation, and it's not. So let me go down to the bottom. Right here. Now let's do Control D, and let's make it one more time. Okay, now let me go into pout.dat. Let me see, how many particles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have all 10 of our particles, which is fantastic. Now, let's do new plot. Good. So this is with us not outputting center of masses, and you can see it looks a little bit cleaner. What I want to do is change the line color, but I don't remember how. Hey, fled from nowhere. How are you? Physics boys. Yeah. A 1 minus 1 is just one of the power laws. Should be written like so. Yeah. Don't worry about it, man. As long as you're still civil in chat, should be okay. So let's go here. What do I want to do next? I want to, I want to change the line color, and I always forget how to do that. So change line color. New plot. Okay. Let me see. Line color type. What am I doing here? Let me go here. Line color. Here we are. Line color 1. That's fair enough. Line type RGB cyan. That's what I want. Something like that. Let's go over here. Where are we? VI cube plot.gp. And we're going to say LT. 1 second. LT, where am I? RGB cyan. And how about we just change it to red for now? Hopefully this will work. Right quit. New plot. Okay, good. So now the particles are red. It doesn't help that much. It's just because everything was purple. It was kind of hard to see everything. Okay, so now let's make sure that all the particles have exactly one box. Okay. So from here, it kind of looks like this guy has his own box, obviously. These guys look like they probably have their own box. All these guys look like they probably have their own box. But let's go down just to be sure. Okay, their own boxes are there, just fine. Yeah, these three definitely have their own boxes. That's great. Okay, now let's look up here. This guy has his own box. That guy does too. So does that guy, I would say. Oh, actually. Wait a minute here. This guy's box looks the same. 1 second. This isn't actually easy to see. Let me see. So this guy's right here on the line. Maybe he doesn't count in a box. That'd be interesting. Let me see. You need to overclock that i7 to check if you're a Silicon lottery winner. I mean, it's fine. Actually, 0 to 0 is indeterminate. Some mathematicians find it practical to define it as 1, which simplifies a lot of proofs. Oh, Kadix, you're actually a mathematician. That's super cool, man. I feel like I knew that. I don't remember how. Okay, so let me see if we can figure out where this particle is. It looks like it is... Oh, it must be counted in this box right here. Let's control scroll in. And let's move it around just a little bit. Yeah, I think it's being counted in this box in there. How do we... Yeah, that should be okay. You could also assert that every leaf particle size less than or equal 1. You can also assert that on every leaf particles that size. Yeah, that's fair enough too. Yeah, let's do that actually. Let me go over to the top and let's include CAssert. Okay, Now let's see if we can do that. Please help with my calculus. Oh, sorry about that, Cadix. I just need a stellar grade in A-level math to get one of my more competitive comp sci undergraduate programs. Oh, I see. Fair enough. Slayer Darth. Okay. He's a mathematician. He's definitely way better. I'm only using linear algebra for 3D graphics goes. Yeah, and honestly, I use it for physics, and I'm really bad at it. So let's go down here. What do I need to do? When we're creating the occ tree, basically what I want to do is say, 1 second, how do we make this assertion? I'm not actually quite sure. So let's see, find center of mass. Make occ child. Okay, so here's where we make the children. I don't know how to make this yet. Bezier is probably what he meant. Let me go up here. Let's not worry about the assertion now. I'll think about this in a bit. Now, let me change the number of particles. I want to try way more particles, just to see if we can get this guy to lag up. So let's see, create random distribution, and let's say 1,000. Right here, Control D, and let's do a quick make. Okay, so here we are making it. Seemed to make just fine. Now let's go into new plot. Okay, here is our occ tree. Yeah, that's a little laggy. But it seemed to run just fine. You see what I'm saying? Like, it seemed, even with the particle output and everything, that was quite quick. So let me see. I'm just going to continually increase the number here. But what I want to do is not output anything to a file. I just want to see I just want to check something real quick. I know this isn't the thing that's going to take any time at all, but I just want to see if we can get it to freeze up at 1,000,000. I realize this is kind of a silly thing to do. Let's do Control D, make. Okay, obviously it takes some time to do its thing. But what's nice is it's not that slow. You know, 1,000,000 particles is a good number, way more than we ran with the molecular dynamics code. Here we are building the tree, taking some time. But honestly, when compared to how long it took to draw, let me see, compared to how long it took to draw even our simple lenses, this is relatively quick. I mean, if we weren't outputting all this to the terminal, we'd be set. Okay, so now let's go ahead and Control C this guy. We could have let it finish, but that's fine. Let's go back to 10 particles for now. Let's go over here. And let's continually output data. Here, let's do an XX there, write this, go over here, make it one more time just so that everything's clear. And let's run our new plot file one more time just to make sure our occ tree is set. Yeah, that looks pretty dang good. If I, you know, I think this is exactly what we need. Okay, so now we have 30 minutes left. It is unfortunately not enough time to really dig into the next bit here. However, let me see. Fled from nowhere. Mathematicians are like different species. I mean, truth be told, people say that about most scientists, right? And I consider math kind of I don't know. There's always a debate whether math is considered science or not. For me, I figure it's like, you know, as someone who does theoretical physics, like if someone can show me the math, I trust it implicitly, you know? So it's like one of those things that makes the science make sense, you know? I don't know. A to the -3 is A0. Yeah. I studied German at A level, got an A star for it at GCSE, but couldn't be bothered to put in the work at A- level, so I scraped a D. Oh, interesting. Yeah, fair enough. Okay, so yeah, this is actually turning out quite well. We have our occ tree code basically set. What we need to do next is implement what we need for the forces. Now, like I said before, the let me see. You could do it, but try to trace some example Bezier curve. Oh, we're talking about Bezier curve. Sorry about that. Based off logic and doesn't depend on empirical. Math is not science. Math is based off logic and doesn't depend on empirical. Maybe you're right. Maybe, I don't know. So I'm actually curious to see what your opinion is, Cadix, if you think that mathematicians should be considered as scientists or not. Like, you know what I mean? Because I don't know. I'm always hit and miss. I think maybe they should be considered a separate category, but at the same time, like I need math. Like without math, I know I couldn't do my science. So at some points, I'm doing math research instead of physics research, if that makes sense. Okay, so let me check. What do we need to do? Okay, so when doing the Barnes-Hut algorithm, let's go ahead and describe what we need to do next. See how much time's left, see what we can do with that. So let's pop over here. New plots plot, page, new page before. And let's see what we need to do. So, where's my board? Here it is. Good to go. Okay. So, when it comes to the Barnes-Hut algorithm, let me go ahead and pull my notes so I don't accidentally say something stupid like I always do. Okay. Put this up here. Hopefully this is okay. Oh man, I have so much stuff on my desk. Okay, good. So, Barnes-Hut. The Barnes-Hut algorithm has a couple of different parts to it. The first part is, of course, the octree code, which is what we have been working on up to this point. And honestly, we're getting pretty far with this. Like, I think the octree stuff is done. I was expecting it to take more than a week, but I guess, even though I've been consistently distracted with all of these streams, it's not as hard as I thought it would be. So next, we have to actually modify this with the force integration. Let's do force integration. For this, I would like to, unless you guys have any objection, just because I know how to use it, use the Runge-Kutta method, so RK4. It's a pretty simple one, makes a good bit of intuitive sense. We could use another better force integrator. I'm sure there are others that are more efficient, but this one should do okay. You know, I think it should be fine. Now, like I said before, this step here will probably take a few days for us to implement, but shouldn't be that difficult. Here's what we need to do. We need to go through all particles, so let's take step 1, go through all leaf nodes. And of course, we don't know exactly if it's a leaf or not, so we can just do our depth first search, and that should be fine. And then we need to figure out which particles. How about this? Figure out what the particles are feeling. Forces the particle feels. Now this seems kind of weird, right? School math teachers suck. I can tell you that I have a similar experience where a lot of math... So here's the problem. A lot of my teachers in high school they wouldn't see the beauty in math. And so they'd just give you the math. They'd be like, oh, this is just true. You know, they'd just give it to you, and they wouldn't explain why it's cool, you know? And so it's a situation where I think it's just being taught incorrectly. Like, if we had people out there motivated to teach students things and like showing why it's cool, showing like, you know, these interesting things about mathematics, you know, I think it'd be fundamentally different. In fact, I honestly think that if we just revamped science and mathematical education, at least in the US, like, we wouldn't have as many ignorant people. The other thing I want to point out is I learned most of my math from physics, you know? I learned it from basically Griffith's electrodynamics and a quantum book and stuff like that. That's where I learned all my math. I did take, obviously, courses on it, but I just didn't learn very much in those courses. It wasn't until I saw it applied to something, and maybe there's something there. Maybe inherently in the application of math, we see its utility in a way, and we see how it's useful. Yeah, Griffiths is great. I always have it around, like, it's right over there. It's underneath my numerical recipes book. Okay, anyway, let's go ahead and figure out what the particle forces the particle feels. This is done actually quite interestingly, and this is really beautiful in my book. Here's the idea. We have all the particles. Let's just draw them out over here. And let's say we have a big cluster of particles here. Here's our cluster of particles. Okay. So, in some sense, this particle here, let's say over here, feels forces from every last one of these particles. So it feels one from here, feels one from here, feels one from here, and feels one from there. There. Okay. It also feels one from each of these individual particles in here. However, at some point, it becomes more efficient to treat this as one giant particle. And this is where the beauty of the Barnes-Hut algorithm comes in. Oops, that was a little bit too long. Basically what we do is we have a parameter that's often denoted as theta, and it's often denoted as S over D. The thing is, they don't really do a good job of describing what S and D are. So how about this? It's going to be equal to the group distance. Okay. Over. Let me see here. R, which is the group radius. Okay, so this means at some point, this theta is our threshold. And the idea is that if we are within this threshold, right, which is basically the size of this guy. Let's draw here. Group radius over group distance. Oh, oops. How about this? I'll just say red. Oh, that was a green. Just notice you have stars turned on. What do you mean stars turned on? 1 second. Let's go here, and let's go there. Okay. I missed a couple things real quick, but let me finish this up, and then I'll go from there. So group distance over group radius. So basically, depending on how big the group is and how far away it is, we can actually treat it as a single unit. And that's quite nice. So if we are within this threshold, we count it individually. If we are outside of this threshold, we count it as a individual unit. So the asterisks. Oh, yeah, I mean, for cursing, I think I have it on. Yeah, it's just curse words and things like that. It's not that I necessarily am afraid of those. It's that they can be used in many incorrect ways. So we have S over D here. And this is super interesting. This is how we cut things off if they're not useful. Now, how are we going to do the force integration? The force integration will be done with RK4. And just so that we have an idea of how this works, because there's a lot of questions. A lot of people have questions on how RK4 works. Here's what we're going to do. We know that I'm already there. F is equal to the gravitational constant times mass of one object times mass of the other object over r squared. It's equal to ma. If we're looking for the acceleration, that's going to be gm, mass of one big object. The m's cancel out over r squared. Here's our acceleration at any given point as a function of position. The g and the m are basically constants, or they will be constants for this particular simulation. Okay, so this is going to be Ra as a function of r. Here's how we're going to do the Runge-Kutta method. What we'll do is we will calculate 4 different constants, which are typically denoted as k1 through 4, but in our case we'll denote it a little bit differently because we have to calculate the acceleration and the velocity and the position. So because we have to calculate all 3, I'm going to notate this a little bit differently. So here's how it's done. We first calculate x1. We say it's going to be equal to x0, where it was initially. v1 is going to be equal to v0, and a1 is going to be equal to gm over r being the radius, r squared being the radius from where we're at. On the other hand, games are so full of linear algebra, like the whole vector space transformation mess needed in rendering pipelines. As a compromise, I'll propose this. Discrete math is cooler than both of them. Okay, so then we do this. We calculate all of these x1s and stuff like that. We then move on to the next one, x2. x2 is going to be equal to x0 plus 0.5 times v1. Let me see. Times our time step, which is going to be dt. v2 is going to be equal to v0 plus 0.5 times a1, whatever it was before, then times dt. And then we're going to say a1 or a2 is going to be again equal to gm over r, where r is actually in this case going to be x. My apologies for that one. x squared, where we use the x1 to calculate this. It basically keeps on going from here. So we say x3 is going to be equal to x0 plus, which is 0.5 times v2 times dt. V3 is going to be equal to v naught plus 0.5 times a2 times dt. And a3 is going to be equal to gm over x2 squared. Okay? And then finally, x4 is going to be equal to x naught plus, what do we do here? It should just be v3 times dt. v4 is going to be equal to v plus a3 times dt. And a4 is going to be equal to gm, oh, that was supposed to be g, over x3 squared. Okay. I missed a whole bunch over here. Like vector space is harder, algebraic structure is not like this. How can you live without seeing the memes? I feel like, in some sense, I'm free without the memes. Like I'm not chained by them. But it's okay. So one thing to point out here. Then after this, we're gonna say x. 1 second. Is going to be equal to the following. It should be x naught. I think I added x naught too many times. Plus dt over 6. That was supposed to be a 6, looked like a g. Then we're going to say v1 plus 2v2 plus 2v3 plus v4. There we go. And we do the same for v. So v is going to be equal to v naught plus dt over 6. And this is going to be with acceleration. So a1 plus 2a2 plus 2a3 plus a4. Okay? So, this is how we're going to be finding the position and the velocity. Here's one thing I want to point out, because a lot of people seem to not fully understand where the RK4 algorithm comes from. So, here's what we're going to say. V is going to be equal to a times t, right? And x is going to be equal to v times t. At heart, that's what at its heart, that's what we're doing. We have some sort of position, and we're multiplying some sort of times some sort of velocity. So this is simply x naught plus v naught t. And here we have v is equal to v naught plus at, right? So we're essentially saying v at any given time step is going to be equal to whatever it was before plus at. And we're saying x is going to be whatever it was before plus vt, which is inherently true. It follows from the kinematic equation. X is equal to x naught plus v naught t plus 1/2 at squared, right? So following this, the Runge-Kutta method kind of follows out naturally. And this is kind of what we'll be doing here. We just kind of calculate a whole bunch of different parameters and we do some estimates. 4 different estimates every time step. Well, I guess 12 different estimates every time step for position, velocity, and acceleration for every single particle on the map. And again, this is why we need to kind of keep track of how far away the particles are and whether we can treat a cluster as a cluster or not, right? So what we'll do is we'll go through all the different nodes. And if one node is sufficiently far away, its theta value is beyond the threshold, we'll treat all of those internal nodes as if they're just one particle. And that's why we needed the center of mass, because we'll treat it as one particle that's collected in that one center of mass. And that should, if I'm not mistaken, be all we need to do from here. From there, we'll see the particles move about every single time step. We'll redraw the tree, redo everything. So it will take some time, and we're going to have to do some parallelization, but I'm not sure where we're going to be able to do that parallelization. So we have to kind of think about that. The other thing to think about is visualization, which I mentioned the other day. What I'm thinking about doing, because obviously nuplot's not going to work for a very large number of particles. You saw that just a second ago. We could use Blender again. I don't mind Blender. I like it a good bit. Or we could draw our own with OpenGL, or even Vulkan, I suppose. But I think it's probably best to start with OpenGL, since, I mean, that's, currently tested, and Vulkan is still kind of new. So, it's kind of up to you guys. We can use Visualization Toolkit, VTK. We can use OpenGL. Totally up to you guys. I don't mind which one you want to use. Let me think. At this point, let me go ahead and clean up what we have currently with the code, and we'll go from there. Let me know what you guys are thinking. Again, this is where we're heading using the Runge-Kutta algorithm for here. You should be able to parallelize the whole thing per particle. The whole thing per... Oh, I see what you're saying. Sure. Yeah. We'll take a look into that. Okay, so as far as things to do in the future, let's go ahead and write some notes. Go to the very top here. Because again, I don't want to necessarily get into the Force integration today. I think I'm going to leave that for Monday. And we will work on everything else from there. So depth first search, this is basically done. Visualization still needs to be done. The question is, use OGL, Blender, or VTK. Up to you guys. Once you reach integrals and differential equations, that's where your journey ends, and math suddenly gets like, sorry, we don't have a way to express this antiderivative with elementary functions. Okay, so now we're going to say separate particle structs. This is already done. Okay, one thing that we also need to do here, thinking about visualization, thinking about force integration, there's one other thing we needed to do. Oh, implement theta, which actually shouldn't take too long. So, in terms of visualizing, we basically need to go through, find a leaf node, and figure out what that leaf node sees. So I guess this is all kind of in the force integration thing. Okay, let me go through, check the code real quick, make sure there's no glaring things to fix. We can move all this into a header file, but that's fine. We'll leave it. We'll leave it for now. Divide octree. Seems good to me. Okay. No particles in box. Still should be okay. I wouldn't use raw OpenGL for visualization. If you want to go that route, look into SDL or SFML. The first has C-like, second is C++-like API. Hey Skynet, what's up? Okay, so I'll look into those. I've heard about SDL before, but not SFML. Let me look into that one. SFML. Okay. And guys, we have about 10 minutes left in the stream, so if you have anyone you want me to host, let me go ahead and let me know now. So again, you just go to Simuleos, you just go here, click on, there should be like a programming tag or something, but apparently there isn't a programming tag. So I guess just go to twitch.tv/creative. I'm doing great, Skynet. Thanks for coming in. And then just go to programming. And feel free to just let me know if you want me to host anyone. And I'll totally host that person at the end of the stream. Go ahead, pause this one. libcinder. Oh, I've heard of Cinder before. Open link. Let me see what we got here. Cinder. Powerful intuitive toolbox. Cinder is a free and open source library for professional quality creative coding for C++. Huh. 1 second. Cinder is a library for program aesthetic intent. Huh. How is it in terms of like speed and stuff? Is it? Let me see. Gallery, learn, docs, forum, download. Gallery. I feel like these look quite good, but I feel like they're real life things. Here we are. Those don't look like real life things. Actually, maybe this is worth looking into. I'll take a look at that one. That's definitely one to look into. How does Cinder compare to OpenGL? I feel like, does it use OpenGL? I'm not sure. We'll take a look at that a little bit later. Okay. So I think this is all set. What I'm going to do is commit this to GitHub along with the new plot file. Then let's see. Yeah, man, this is still rather messy. But that's fine. It's about as good as we could come up with. And let me run one more thing real quick. Just the octree code one more time. With about 100 particles. And let me see something real quick. And then actually might be it for today, guys. I realize, yeah, sure, Skynet, you just came in. My apologies there, man. But we're kind of winding down with this one. We'll work on the force integration again, let's see, on Monday. I'm going to take a break this weekend while I kind of figure out what we need to do for visualization and stuff like that. Let's go ahead and make it. Took absolutely no time at all to make. And here is our octree code. And man, it looks exactly like what we want it to look like. This is great. I'm super happy with this. Good, good. Yeah, that looks pretty dang good. I'm happy with that. /configure make sudo make install. It's like really requesting a consumer. Let me see. Oh, I mean the truth is, guys. In terms of intelligence, right? Like, I don't think anyone is like naturally intelligent. I mean, there are some people who just get things faster than other people, but I think it's a matter of just, you know, learning things. If you're interested in learning things, you just become more intelligent in that area, you know? Good, so this Octree code looks like it's probably working just fine, which is great. This means that our force integration stuff should work very well. I'm expecting that to take a day. I'm expecting visualization to take a few more days. I honestly think we're pretty close to being done, which is great on the one hand, but then I don't know what to do next because I hadn't planned that far. So if you have other simulations you want me to do, I will take a look at this. I'll take a look at it with a little bit more detail. I guess that's true. I didn't take into account different psychological issues. Gauss. Okay, so let me go ahead and Control D here. Let me run a quick git status on the current directory. Okay, 1 second. Oh, I know what happened. Okay, so let me do git add barns underscore hut.cpp. And now let's do barns hut.cpp. Makefile, obviously is necessary. Then we want qplot.gp. Should we make it so that qplot... It's okay, this is fine, Vector.h. And let me go over here with notes. And let me say to plot. To plot, use the following. Oh gosh, that was meant to be a star. New plot. Cube plot. .gp minus. Let me try that. New plot. Cube plot minus. Yep, that's exactly what we want. Good. Okay, so let's go Control D there. And let me open up Barnes Hut one more time. Good. Now let's go ahead and enter. Git commit. And let's see. Adding changes. Vector compatibility. Probably shouldn't put it there. Smelling like a chicken. Tag out his PhD at 21. That's fair enough. Okay, what am I doing? Adding vector struct / vector.h. What else do we do? Completed Octree code and visualization with new plot. Do we do anything else? Preparing for force integration with RK4. Good. Right, quit. Git push origin master. And there we are. It is now available on github.com. Feel free to take a look at it. What am I missing in chat? In other words, you usually just game for 3 days straight while waiting for your stuff to render? Yeah, well. I need to take a shower smelling like a chicken. I'm sorry, Flood from nowhere. Unfortunately, that hits very close to home. Watch out with that one. Object-oriented programming is not the silver bullet. A lot of people make it out to be. It has its uses, but a lot of time functional style will serve you better. Yeah, I actually need to learn more functional programming, you know? In fact, I'm not really even using object-oriented programming, really. We'll see how it goes. Anyway, guys, I think that's it for today. I was kind of sort of dawdling there at the end, but, you know, we got there. I'm pretty happy with how far the simulation has gotten. We have the Octree code done. It only took a few days. Could have taken even shorter time had we moved more efficiently through the code, but that's okay. That's not the point of the stream. The stream is just to implement things together, and I enjoy talking to you guys. It's a lot of fun. So that's it for today. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, which will be on Monday. I'm going to miss tomorrow, which is Saturday for me, and the next day, which is Sunday for me. And then I'll be back your Sunday night, which is my Monday morning, for the next stream, which will be on implementing the Runge-Kutta method for this particular system, which we discussed a few minutes ago. And that's about it. So thanks guys so much for watching, and I'll see you next time. Bye guys.